Hi guys, welcome to Microsoft Build 2017. Thank you so much for joining the session today. Today we're going to talk about delivering world-class game experiences using Azure. Quickly introducing myself, my name is Gautam. I work as Senior Program Manager at Microsoft in Developer Experience Group. Today we're going to talk primarily three things. We will have a very high-level Azure overview for folks who are relatively new to Azure, game developers, indie game developers or game studios who are looking to move their cloud back on Azure. Second, we're going to talk about common Azure game scenarios that we see, and also based on experience with the game studios that we have worked with, what are the common game service architectures that we see on the cloud. And third, we will dive a little deeper into the experience of building Hitman game from their makers, IO Interactive. So on Azure today, we actually have a lot of great games running in production already, starting from our own first-party games like Halo 5, a big AAA game studio, in-house game studio, and they have this title, to console game like Hitman from IO Interactive, and also a PC game, a web-based game like Age of Ascent from Iliad Games in the UK, to a mobile game very famous and popular on iOS from Next Games, The Walking Dead No Man's Land, based on the popular TV show. This session is really about the different lessons we learned from working with these different game studios and partners, and getting it all together and packaging that to you in this session. Before we dive into Azure, let's take a step back and look at what options Microsoft has for game developers like you. So if you look at this stack in this slide, let's start with the bottom band, which is Azure. So essentially, if you planning to build your game backend and you want to put that on the cloud, Azure gives you the basic building blocks that you need to make this happen. So Azure essentially gives you compute services required to run your game. Then you have game data services to store your game data, player management data, game logic state, etc. And also game analytics. So today, free-to-play games is sort of the norm, and it's very different model than in the past era where people would pay the cost of your game upfront. So in game analytics services, what you could do is things like understand your behavior of the players, understand what is selling well, so that you can monetize your game very effectively. And we'll talk about this in a little detail later. And also the basic networking services. Let's say you already have an existing on-prem infrastructure, be it in your own data center or with a hoster. How do you connect that to Azure? Or how do you even connect the different services within your cloud to each other? How do you manage the load? How do you balance them? All those things, basically networking services. Now on top of that band, we have the Open Xbox Live band. Essentially, Open Xbox Live is a collection of managed game services built on top of Azure. If you followed us in GDC early this year, we made a bunch of announcements there, and we opened up the SDK to platforms beyond Xbox and Windows for other mobile platforms as well, and we launched the Xbox Live Creator program. So you should definitely check them out. They have a few services which you can readily use out of the box, done for game developers. If that's all you need, you should start there and then go down to Azure. And as Microsoft, we love partners, and we have a great partner solutions available running on Azure today. Example, Photon, a multiplayer engine from Exit Games, runs on Azure. You can deploy it on Azure, and a lot of gaming as a service partners like GameSparks, in the Western world, Shepherds and Playblazer from Asia. They have catalog of services for player management, level design, score management, etc., where you can just plug and play and run. And now when you're building your game, which is the topmost layer, you can be building a mobile game, a web game, or a console game, and even there, the tools that you would use with most of the top gaming engines like Unity and Unreal, they have good relation with us from a Visual Studio tool perspective, and they use Visual Studio as a first party choice for all development, right? So that's how you basically touch Microsoft in your various life cycle. Now let's take an example. Let's say you're building a game. Where do you start? Actually, you can pick and choose the different blocks, whatever serves your need. As an example, if you're first time moving say your existing cloud backend servers to the cloud, you can start by picking a virtual machine in under Azure to run your game server, and probably say for achievements module you can look at Xbox Live as an option, and if you want to enable multiplayer session management capability, you can look at Photon server and deploy that on Azure, and all of these three things together can basically be your cloud backend, and we will dive deeper into these topics today. And in this session specifically, we will focus more on the Azure layer today. Okay, now let's step the gear to the Azure overview. First things first, so what is Azure really? Azure is essentially a collection of enterprise grade services to run mission critical applications on the cloud. In this case, of course, games. There is a lot of different services, and this slide is quite mouthful. So from your perspective, just connecting this back to the previous slide, all you need to think about is you have services to run your game compute, game data, game analytics, and networking, and we will dive into these topics later in the session today. And Azure lets you develop with technologies of your choice. And Azure is an open and flexible platform. What does that mean? On Azure, you can run any type of game, be it a mobile game, an online social game, or a PC and a console game. You can be targeting any type of game client. It could be Android, iPhone, Windows Phone, Windows PC, on console, Xbox, or even PlayStation. And if you're specifically targeting mobile platforms, we have excellent support with Azure Mobile Services, which gives you SDK on the client side, through which you can connect to Azure very seamlessly and have a great productive experience for developers. And you can be any type of company, and Azure has a very flexible payment options. For example, if you're an indie developer or a small game studio, you want to start with a simple web direct, pay as you go payment model and pay only for what you're using, perfect, you can start there. Yeah, if you are an enterprise, large game studio, and you want to basically looking at an enterprise agreement kind of a payment option, you obviously have the two. And what does it mean from a technology perspective? You have a broadest selection of options for your operating systems, for your programming languages, open source frameworks, tools, and databases. For example, you can obviously choose Windows, you're talking to Microsoft, or obviously different flavors of Linux. If you want to do containers, yes, Dockers too. If you want to use database or first party SQL database or MongoDB, which is very popular with game developers, and so on and so forth. So what does this really mean to you as a game developer or a game studio? Basically, if you are coming to Azure, you don't have to reinvest in skill set of your team. And Azure gives you a choice of different technology options. All million of developers use today, and they trust and they live and they breathe. So you can easily come to Azure. And Azure gives you the capability to reach your gamers worldwide. What does this mean? If you look at our global footprint of Azure data centers today, we have about 38 Azure regions worldwide. We are actually almost double compared to AWS, and that's a huge differentiator on Azure. And also we're making huge capital investments to increase our global data center footprint. As an example, we recently launched data center in Korea, which is a huge gaming market, and we are the only public cloud in China, which is another huge mobile gaming market. But what does this really mean to you as game developer again? What this means is you can have your game backend logic as close to your players as possible. That basically means less latency and great game experiences, which means to you more money which you can monetize. And second, if you are really looking up to some of the platform as a service offerings on Azure, for example SQL DB or DocumentDB, it has some out of the box features to replicate your data across the data centers very seamlessly. For example, if you take DocumentDB for example, which is very much similar to MongoDB in terms of the NoSQL data that you would handle there, in Azure portal you actually have a screen which has a global map like this. Initially, let's say you targeted US as the market, and as sort of you saw interest in the game coming in from Asia and you want to now cater to that audience more effectively. Literally what you do is on the in the Azure portal, you click on the Asia data center and hit on a submit button and you're done. And in matter of minutes, your entire data replicated in the Asian data center, you're now closer to the users. Think about doing such a thing in an on-prem world, the kind of skills that you need to have, the amount of work that goes into it, it's sort of done seamlessly as a magic for you. So that's the benefit of moving to Azure and using platform as a service offerings. And next, it's very important, for game companies to be able to reliably scale at a moment's notice. Basically, this notion of hyperscale. When we worked with the game studios, these were the learnings that we really came through. Predicting resources usage is really hard because we worked with a small game studio. It was their first game on public cloud. They were not very sure how popular the game is going to be. They planned for a maximum of 1,000 users, say in a month's time, and that's what they really started with. But then they realized the game really got quite popular, and they actually started hitting about 2,000 to 5,000 users, and they could actually manage because they were on Azure and they could really scalable architecture that they had, which brings to the second point on the slide. They were able to scale automatically, fast, and when they need it. And also it's important to be able to absorb the largest resource utilization spikes one might expect. For example, let's say you're launching multiple game titles around a holiday season and you have this massive spike. You obviously need to be able to handle that, and that doesn't mean and shouldn't mean that you're buying a huge hardware and managing the cost required to keep the service up and running. At the same time, when you're past that spike of holiday season, you should be able to very easily take it down and then again manage your cost. And also on a daily operations perspective, it's very important that you're able to quickly provision and in parallel create thousands of virtual machines or Azure resources, because even within the day there could be a huge demands and pipes. You shouldn't be required to have idle capacity to be planned in advance. In Azure, for example, in matter of seconds, not even minutes or days, you can provision kind of VMs, and hence you can really scale up and down as you want, and then it's a great thing to have at your fingertips. Now, from a hardware perspective, on a data center, we have made a lot of good announcements in the last 1 year. First one being F-series virtual machines. Basically, what F-series is all about is it's high-speed, compute-intensive virtual machines, and they use the latest Intel Haswell class CPUs to give you really good performance. Basically, in F-series, what happens is the CPU to RAM ratio is around 1:2. Like you will have a 2-core 4 GB machine, for example. In the past, before F-series, if you needed high CPU, you only had to look at D-series machines, and they generally have a very high memory, which you didn't need it, but you also had to pay the cost of a D-series. So by using F-series, your cost goes significantly less compared to D-series, but you still get the same performance that you need for a compute-intensive workload like gaming. And also, N-series virtual machine is very interesting. They basically are GPU-based virtual machines for you in the cloud. We're seeing a couple of trends in the gaming industry today. One is even for 3D rendering, for the 3D models, modeling that you would do even before getting the game out there. Instead of like buying this huge, crazy, big workstations and then working on that, and then you're rendering, you're waiting for it to come back and all of that. People are looking at an option whether they could actually keep all this big workhorses on the cloud. You just VPN to it, and you do your stuff, and then you basically do the 3D modeling, and it all stores on the cloud, and so there's no time lost in uploading and downloading this huge amount of assets it creates, and can you really do that? And obviously you would need GPU to be able to do all of that on the cloud. And from a gaming perspective, the another trend that we're seeing, especially with 5G coming in and the bandwidth becoming so fast, imagine let's say a space combat Star Wars sort of a game, and you have thousands of spacecrafts around you, and they're shooting at each other, hitting the other buildings, and or the spaceship, and the debris is falling on you, and you need to compute this and visualize the whole experience, the lighting and shading. Instead of you doing all of that on a game client, which is limited on a CPU, would it be nice to put all this physics-based computations and run it on the cloud, basically on a GPU-based virtual machines? And many of the gaming studios are exploring that, and you can definitely try that out today and do such things on Azure. And also, it's very important, very fundamentally, to have high reliability on virtual machines, and we take this very seriously in Azure Engineering. Obviously, we have our SLAs. We recently announced a single VM SLA as well, and we monitor this almost on a weekly basis, and it's going pretty up. And you should definitely look up to Azure, and then it can serve your needs. So now let's take a pause and watch what our friends at Next Games did for the game Walking Dead No Man's Land, and let's hear it out in their own words.
We're really proud of the fact that we're actually helping humankind learn how to rebel walkers and stay alive. Azure is a key part in that training. You have to be able to do that 24/7 just to be ready. Walking Dead No Man's Land is based on the AMC TV series. We can actually provide new content after each episode within 24 hours. I pretty much knew that with choosing Azure and Microsoft, I would be guaranteed with better support than I would get from any other cloud providers. We know that there's somebody there looking after us. In Azure, we have, I don't know how many hundreds of servers, but then again, why would I care? It's cloud. The latest addition that we've been starting to use in Azure is DocumentDB, which has really helped us to make our development cycles faster, and that actually enabled us to create a very engaging player versus player experience within the game. Many of the things that we would usually need when we're doing backend are already pre-figured out for us by Microsoft. And we were able to deliver such a high quality, engaging game with stunning graphics, good gameplay, and reliable technology.
Awesome. In fact, incidentally, our biggest customer for DocumentDB is actually them, and it's a gaming company. So that will tell you how much of data processing any gaming company would need. And then they're awesome partners. And in fact, they have a session of their own at Build, and Kale and his colleague is presenting on their experience. So I would strongly encourage you to watch that session as well. Awesome. Now let's switch gears to the second agenda item for today, which is common Azure gaming scenarios that we see and typical architectures that we see around that. Let's start with game compute. So what's the scenario here? This is the most basic scenario. You basically want to get your game servers, which is managing your players, your game logic, any sort of communication between the players or the different services, different mission, all of that on a compute node, right? So there you have obviously a couple of options. So you can start with the most basic option, which is virtual machines, which is generally referred as infrastructure as a service. So what happens there is you can choose Windows or Linux based on what you need. And you get a virtual machine up and running on the cloud. You can migrate pretty much if you already had an Hyper-V or any such virtualized environment already in on-prem. You can easily migrate it to the cloud. But there you have complete control. You also have full flexibility, but you also need to manage. That responsibility is on you. You need to patch the operating system, keep it up to date, running, and everything. At the same time, if you look at our PaaS services like say app service, for example, there you really don't deal with VMs, though you know exactly what you're running on. You can pretty much like get your stuff up and running over there, and we will manage the virtual machines for you. And obviously you have less control and flexibility, but that's not really true. But you can, if you want to, you can go as deep as you want. But then we take off a lot of responsibility from you, so you can focus on a game logic and your code than really managing the infrastructure. And you have a lot of options in between. For example, if you want to run any container or container orchestration based logic, you can easily do it on Azure. In fact, Azure Container Service on Azure is the only service on public cloud market today which supports all the 3 top container orchestration tools, basically Kubernetes, DCOS, Mesosphere, and also Docker Swarm. And also, if you're looking to build a microservices architecture, we have Service Fabric. In fact, most of our first-party services like SQL DB and even Skype and Bing, many of such services run on top of Service Fabric, and we also can provide you, and we're seeing a lot of traction with that service. I'll talk about that architecture a little later in the deck. And also, if you're looking at very high level function as service, new trend, and quickly do some things, connect disjoint things, and that sort of a thing, and you also have functions. And also, if you are typically a web-based game developer, then you can obviously look at web app 2 as a great option to host your entire game in a web app. Or if you're just hoping an API or REST APIs and do it, you can still look at web apps. And the best part is you can also take bring any other custom compute solution like a Photon server, for example, from a marketplace and run that on Azure. So there is really nothing that limits you from running anything else as well. And for all the options that we have, you can scale automatically and on demand as you need it. Now let's talk about data. Right, so what are the scenarios here? So you might already have a database that you're running on, let's say MongoDB. You want to run a MongoDB on a virtual machine on Azure, very happy, you can do it. Or if you're okay considering platform as a service offerings, you get a ton of benefit in doing that. You have again a lot of options like a blob storage, where typically load things like image, basic data, basic binary stream of data really, or table, which is sort of a low SQL very scalable storage solution. If you're looking at a relational SQL database, we have SQL DB, which is sort of our version on the cloud, which you can look at. Or if you're looking at a NoSQL database, you can use Document DB, and I talked about Document DB earlier, and Next Games uses it extensively. And also you can for a leaderboard sort of a scenarios, you can Redis is a very good option, and we have a support for it like first party in Azure. Or if you look dealing with big data, you have things like Data Lake, Data Factory, HD Insight, you can look at that too. Or again, if you're very niche scenario, you want to use things like Cassandra or DataStax, you can also bring those services and run it on top of Azure over here. This is all about data storage. Where you can store your game data, player logic, state information, etc. Now that's third scenario where everything sort of comes together, and it's very important for game developers, especially in the free-to-play model, is analytics. When we talk about analytics, there are really 3 scenarios, right? One is when you have your game running, you want to know what happened in the game, like what users are doing in my game. What weapons are they buying? At what specific level are they more inclined to buy something new, which will increase my app monetization? Just your player behavior, understanding that past data is super important, so that in the future you can target the right moment of time to give a throw up a weapon, or let's say they are losing or dying after the 3rd level. You basically prompt there saying hey, just pay like whatever $1, and then you basically can get life and continue from where you are and things like that. So that's very important. Second scenario is what's happening right now. In fact, cheating is a big problem in gaming. So there's some weird behavior somebody has figured out, and let's say a level actually takes 2 minutes to cross, and then somebody is able to do it in like 30 seconds. There's something fishy going on, right? And also somebody has like bought huge weapons and then basically killing the experience for others, which you didn't want to basically happen in the game. You can analyze these things as the events are happening currently real time. And third is, now that you have these 2 sets of data, what can you do in the future, what can you predict in the future and control it to optimize your game monetization. So that's what this game analytics is all about, and we're seeing a lot of game studios really start Azure with these set of services and then really going beyond, because you can actually have your computer on AWS, for example, and still be able to run analytics on Azure actually, and we're seeing a few cases like that as well already. So in analytics, we have set of services. Event Hub lets you ingest data at scale. Stream Analytics lets you analyze this data real time. Second scenario. Third is, since there's a lot of data being collected, you want to be able to store it in a big data store like Hadoop. SD Insight is basically our implementation of Hadoop. It supports all the different things that you would expect. And also we have machine learning and cognitive services. So they're basically a set of, cognitive services is a set of APIs to analyze a lot of things like text, vision, and computer, which you can use. Machine learning is interesting, where you can the way we call it like a data scientist, data science for everybody. We're like trying to democratize, data science for people with machine learning. You can build models by literally dragging and dropping, all the algorithms, based on huge research from Microsoft, and then connect these things and then train your model on the data as they're coming in, and they get better to basically tell you with future predictions. Hey, get this weapon at this point of time to basically get this done. Or let's say you have a cool weapon, and you probably thought people would buy it, and then nobody is able to even get to that level to basically see that weapon, and probably want to position it in a little different place. Things like that. It can easily tell you with all this information. Also getting the player information, and we'll talk about this in a demo very soon. Now that you have all this intelligence, you want to be able to see this data, visualized, so that you can take action, and that's where the power of Power BI comes in, where you can visualize this rich data, and we will talk about it. Now let's now that we know the services and the scenarios, now let's put these things together in a game service architecture, and these examples are really built on the real world examples of the partners that we have worked with. So the first one is the super simple game service architecture, which we see most common with mobile games and even PC games to a certain extent. Here it's very simple. You have a game client, mobile, PC, console, whatever it is, and then you have your sort of a web logic or in general cloud logic, which will run on some sort of a compute. It could be as simple as a virtual machine, or it could be PaaS service like web apps, app service, or even a serverless compute like functions, for example, right? So you have set of services to do that, and you get load balancer in Azure, which will basically manage the load to these servers, and to manage your data, which is like your player state, the game assets and different stuff. You have the database that you can use and all the options we discussed. You can use DocumentDB, SQLDB, Redis cache, and then you have them, and then they're also scalable. This is the most basic architecture that we have, and in fact all the architectures we're talking about in this session today are all available to you to just download and play with it. So let me give you a demo of that. So if I go to GitHub, I'll share the link with you in the session. You can go here today and actually play around with these architectures. So here, basically, we have something called as ARM template. So if you're new to Azure, what is ARM? ARM is basically Azure Resource Manager template. Basically, it's a way of defining all the different services you need in your architecture and sort of putting them together. And then you can hit on literally a button called deploy, and it will deploy all of that to Azure, so that you don't have to worry about getting all this stuff installed, stitching them together and things like that. So let's go to the simple game service architecture, and as you can see, there is this button called deploy to Azure. So all you need to really do is click on this button, and if you already have an Azure account like I do, it takes you to the portal directly. Maybe later. Okay. So what happens here is, in ARM template, you can define basically what are the basic configuration details you need to collect so that it can deploy the environment as you need it. So here as that it is deploying to my internal consumption subscription. It is creating a new resource group. Resource group is a collection of all your related services. So I'll say game 20, for example. It's deploying to Eastern US data center. That's great. I'll say build demo, I'll give a username and password, and I'll say pin this to dashboard, and then I'll say oh it's fine, and then I'll say purchase. Okay. Oh, I need to agree to the marketplace statement, and then I'll say purchase. Awesome. Now what it's going to do, it's going to validate this template and actually deploy this to the Azure, right? So while it is deploying, it takes a few minutes to do it. Let me show you how it actually looks like when you have deployed this, right? When it deploys, this basically deploys these following services for you. It gives you event hub for ingestion, which you might need it in the future, even in this architecture. It gives you a simple storage account. It gives you a SQL server on a VM. It gives you a SQL database. It gives you a website, and also it gives you an app service plan, which basically defines the billing around your app service and scalability options over there. So these are the different things it installs. Now you can just go to Visual Studio, and then just connect to this, and get started. If you say don't need any service, just delete it completely. Everything is customizable for you. Now, if you remember the scenario I was explaining on my first slide, I said you can obviously do these things on Azure, but you can also get a partner solution and deploy. So let's say to do that right now. For example, Photon. So I can just come to plus and then say search for Photon. It brings up that it already has an image for Photon server version 3 single node. I click on that. It brings up yes, that's exactly what I'm looking for from Exit Games Publisher in compute category, and it will tell me that it is you can provision this on a bring your own license enabled. Basically, you have get a license from them, you can deploy this, and you can run it on Azure, and you can now hit on create, which will basically really create a virtual machine, package all the Photon server code on it, and then makes it available for you, and you can now just connect to this from your code and then up and go, right? So this is how simple is it to really run or deploy anything on Azure. Cool. Now let's get back to the presentation. Let's move on to the yeah, we did the demo. Let's move on to the second architecture, microservices architecture. So this is something very interesting, and I should definitely consider this if you're building a new game and a new architecture from scratch, and you have a relatively complex game, or you want to use the same cloud logic for say multiple games in the future. I strongly encourage you to look at this architecture. So our first party service fabric is basically based on this architecture, and in fact Hitman game I'll talk about later also uses this architecture behind hoods. So in a microservices architecture, what you really do is you break your game logic into different modules. And it is based on actor framework, so where you can create stateful and stateless services. Here let's say red boxes signify stateful services, and yellow are basically stateless services. So what a stateful service means is you can put the data and the app logic together in the same box. So that way there is like almost like no latency, so they exactly know the state. So it's easy, very easy for this particular solution to be replicated and scaled out very easily. So that's benefit number one. And also let's take an example of Age of Ascent, which actually uses this service fabric behind the hoods. So they created each of the spaceship in that Star Wars combat style game, each spaceship is actually an actor. So what happens is let's say you have hundreds of spaceships around you and everyone is an actor. You need to be able to manage the state of each spaceship in your game, and though there are like 1,000 games around you, you are probably most concerned about say probably spaceships around a radius of a manageable distance, right? And that's what is going to affect your state most likely. Others obviously are important, but you can adjust it later because we're really far in the distance, right? So now to be able to manage the state of a single spaceship, they actually use an actor model and build the whole game logic around that. And the benefits that you get here is like in my I really think it's magic. So let's say this particular server here sort of goes down. Oops. Let's say this server here basically goes down. So then what basically happens instantly is that these two services here basically will go automatically to a different server, and Service Fabric does all that for you. You don't even have to know that this actually happened in your thing, and also it will automatically bring up a new server in a cluster. So everything is around a cluster. You deploy certain missions in a cluster, and everything is managed within a cluster. And let's say now you want to update your game, which you do all the time, in today's world. You don't have to take your gamers down when you're updating your game. You can release a new update, server by server. It will go and basically update this. It's a very seamless experience, and say something goes wrong, then it automatically rolls back all the updates, and that's one of the benefits you get, and you get complete monitoring to what's happening and everything. It's a beautiful architecture, and Age of Ascent uses it, and even Halo uses it to a certain extent. So it's a beautiful architecture, and I'm seeing a lot of traction and on this architecture here. And if you want to deploy it, you also have the ARM template to do that in the same link I showed you earlier. Now the third option is this, which is a session-based multiplayer architecture. Basically, exit games, Photon server uses this similar architecture. Even our first-party console games uses this to manage multiplayer session management service. So what happens here is, of course, you have a game client, but you have multiple game clients, and you basically need to be able to enable communication between these multiple games. Let's say, for example, it's a first-person shooter game, and then I'm playing it for the second time or third time, but I want to try out multiplayer. I want to be matched with another gamer of my same skill ability, and your game should be able to provide that experience. Otherwise, if I'm up with a expert who's played the game for years, I'm going to die in like every few minutes, and I'm probably going to lose interest in the game, which is a bad thing for me, but also a bad thing to you as a game developer, because they're not going to pay money for your game, right? So what in here, what the architecture is, you will have something called as a master server. So the two game clients, when they say, hey, I want to join a game, they basically communicate to a master server, and master server has the details about the skill set of the player and all the rich telemetry of data, and then it will say, okay, fine, this game this game player and this game player of similar skills, I'll put their game on, say, game servers, which is in blue icons there, and they'll play on that server, right? So that I get a better experience, and you're able to manage all of it in the background. And then once the player's skill level get increase, they can basically get to play with higher skill players. So this is how this works. You can run this on basic VMs, but on a virtual machine scale set is a good option here, so that you can scale things out easily, because the basic image of the VM is not going to really change. So this is the session-based multiplayer architecture. Now moving to the fourth piece, which is the analytics gathering I talked about. This is the cool part, to me. What happens here is obviously you have multiple game clients, a lot of players are playing the game. You want to understand what's really happening, what you can do about it, and how do you basically increase monetization from your game. So as I said earlier, you will have an event hub, which will ingest all the data from these different games. Then load it through Steam Analytics, where you can do real-time analytics and show it off in a Power BI dashboard right there, or you can put the data to any data store, really, Blob or SQL or a big data like HD Insight, and then visualize on top of it as well. So let's see a demo of how what kind of dashboards you can build and the power with that. Okay, so let me move to Power BI. Okay, so here in this demo, basically I have sort of built an event generator which will simulate this data, and you can actually plug this to a real game, pretty much as is. It's also part of SDK we built, and I'll show that to you in a minute. So this is Power BI. If you're, I'm sure you would have seen Power BI in the past. Here I have basically 4 games, 0, 1, 2, 3, 4. And in this first chart, I'm actually visualizing the number of active sessions per game, and you can see if for each game how they're behaving and how it's going up and down. And so now I know that probably my game number 4 is the most popular game and where I'm really making money, or at least have player engagement. So I should focus on making money by delivering good experience and being smart about what assets I give there. And also I can keep account of how many players are there for each games. You can see like about 20,000 people are there, and then also number of the average duration for each player when they're giving my name. But this is not a lot of data, but I want to really see where my players really coming from, from which country, right? So one of the cool feature of Power BI is actually you can almost in a conversational English, you can write and ask questions, and then you'll get data. For example, I just clicked on number of active sessions. Now I have actually 288,000 active sessions right now. Okay, awesome. I want to say per country, and it automatically gave me a bar chart. And if I scroll down, there is, oh my god, I have folks from really across the globe, but I'm not able to visualize where to have the maximum users in this view. So I'll say, hey, let's visualize this as a map. And there you go. So each bubble, radius sort of, defines the number of, active sessions in that country, and it's a great view. But I still can't make out, details because they're really spread out across the globe. So I'm going to do this now. I will instead visualize this as a field map, and this query will take some time to go back and populate. There you go. So you can see now that probably have the maximum customers from Germany in Europe, followed by probably Brazil, and then China, India, and the rest of the world. So now I know I probably, if at all I plan a marketing campaign, and to encourage people, I may want to invest in Germany, South America, and then probably next China. But surprisingly, there's not much in US, so probably I should do something different for US. And the best part about this is you can actually pin this, dashboards to your, main thing if you think that's good. So have a little richer dashboard on the same data. So here, of course, I have the number of active sessions here, but this is really giving me the answers that I was looking for right out of the dashboard. Here it is telling me where I have my most number of active sessions by country. I can see it's China, Germany, India, and so on and so forth. I have the same field map here, and I can actually see how many active sessions are per city across the globe. Now the beauty is I can actually filter things down. Let's say I want to know where are people playing from in India, and as you can see, the chart zooms in there. You can see all the cities, and I see wow, 259 people from Ahmedabad and 127 people from Agra playing probably in front of Taj Mahal. That would be cool, and so on and so forth, right? But I want to go to a level deeper and really want to understand who is the player really who's paying for my game. Here you can see that I have basically cool. So I have about 500 players for my game right now. It's showing, and they're playing an average 150 minutes on my game. And now I want to know, let's say, who is it from US who's playing the game, and which cities are they playing from, like Chicago. Okay, let's say who's playing from Chicago. I have really 15 players, and here in this report I can actually see who are these 15 players and who is the player who's playing for the most, right? Now I can go to the next level and even track or build this dashboard on sort of a weapon or a secret outfit and things like that, so that once I have this data, now I know exactly which country to focus on, which cities to focus on, what kind of players to focus on. I can even gain a very personalized notification or a campaign to really get players engaged in my game. And that's how you basically convert all this richness of cloud computing to real money to you end of the day. Awesome. Now let's get back to the presentation. And the beauty, as I was saying earlier, is you can combine all of them in Azure very easily, seamlessly. You can start with one thing, add more resources, put them together, and this is like a combination of whatever we had earlier. And I'm adding Azure Active Directory additionally here to basically manage the authentication. In fact, AD has a lot of services like B2C is really meant for consumer needs, and you can really look up that. You can easily log in through Facebook, Google, any sort of standard identity providers you would expect. It gives you support for all of that, and you can easily wire it up and get your games up and running with the power of Azure. We already see the game analytics demo. Let me introduce you to Nether. So what we've done in DX is in Microsoft, we sort of build this open source project, codename Nether, and we have it hosted on GitHub over there. So all the stuff I'm talking about is actually available in GitHub. You can deploy, so that you don't have to start with basic building blocks, but you have sort of a stage or a foundation to start your projects from. So go have a look at it. Let me quickly demo actually a game that we have built using the different components of Nether. We actually worked this with in a so anyway, so it's actually I can log in through Facebook, and it will actually populate the leaderboard that way, and I can see who is my friends on Facebook, how much are they scoring, so it gives that typical leaderboard competition among the people. I can actually do that, or it's fine, I don't want to log in through Facebook. I've already logged in here, and let me play the game right here in the store. Okay. So I've already logged in here. You can see my name G coming on the left top here. It's a typical space shooter, and you can see the level on the right top, and my score is currently 0. Okay, finally I hit something, and I'm now only in level 2. I should see more enemy ships popping up there. Okay, now I die. So here you can see the leaderboard, and obviously I have the least score in the game compared to my colleagues, and it has a score, and then I can play again. So this leaderboard is actually a module. The score that you were seeing was actually a separate module, and then all these features is basically coming from Project Nether. So let me now take you to let me close the game. Okay, so this is where the Nether GitHub repository is. If you scroll down and click on actually architecture, it will tell you what all services are already there. We have written code for identity, player management, analytics, and leaderboard, which connects to database and analytics pipeline and a bunch of services together. So you can almost download this SDK, connect to this from Visual Studio or any of your favorite IDE, and then get you started with these services. And all of this is open source, so you can play with this data, play with this code, modify it, and also learn from it. And we'll continue to make some enhancements over here. Awesome. Okay, so now let's switch gears to the last part of presentation, which is really IO Interactive Hitman. So before we dive into the technical details, let's watch a quick video on what they had to say about building Hitman on Azure.
My name's Torben Ellert. I'm the lead online designer on the Hitman franchise, being developed here at IO Interactive in Copenhagen. The Hitman franchise is 20 years old. As we know, it's about the world's greatest assassin, Agent 47, a bald-headed, red-tied, snappily dressed guy who travels the world, meets interesting people, and then totally isn't there when they have tragic accidents. So, as we're filming this, we've just finished shipping the Hokkaido episode of Season 1 of Hitman. And this is the world's first episodic AAA game. And it's been a fantastic adventure to get to this point, both in terms of the game itself and how it's been received by players around the world, but also the long journey that we've been on to go from shipping a classic AAA game to shipping an episodic AAA game. And a big part of that has been our technology choices. And one of those technology choices was obviously working together with Microsoft, with the Azure platform as a service. It takes a very different mindset to make a game in this way. Not only because we're shipping it an episode at a time over half a year or longer, but also because we need to think about the game as a platform. We need to think about the game as a sandbox that is talking to servers and us looking at what's happening and creating new experiences based on that. So yes, it's a fundamentally different way of thinking about creating a game. It's enormously innovative. So it's almost like being an indie studio with the muscles of a AAA studio.
It was a fantastic experience to work with IO Interactive guys in Sweden, on this game. Well, for one, it's an awesome game, one of my favorite games. But also the way they looked at the game from a technical perspective. They actually call Hitman as a service, because there are a few things that are very unique to this game. First of all, it's an ever expanding, ever evolving game. It's digital first, and it is episodic, as he explained. They every time there's like a new season, and every few months they have this like a Japan season, like a Thailand season, a Paris season, a new content which sort of gets down to your basically console and you play this game. So and it's sort of a live content and online platform feel to it. So hence the game backend had to be tailor made to their needs. And since they were building this sort of amazing experience, they really want to focus on their game logic than say managing the infrastructure. So they really wanted to have off-the-shelf components to the most things that they would wanted to do. And they obviously wanted to have a managed infrastructure and a scalable infrastructure for their needs. And for the next 3 slides are really their slides and not my slides. And Cristiano did this talk with me at GDC where he presented this slide. So why did they choose Azure? What they had to say about that was primarily they look at Azure as a platform as a service leader. And really the rich toolbox of services that we have on Azure, they can just pick what they need for the right job they have to do it. And then also, interestingly enough, the toolset familiarity with Visual Studio and C# was pretty handy for them and for their team. If you look at how their backend really was, they really took a sort of a web-centric approach. So all communication happens on HTTP, and of course passes through the firewalls, TLS encryption, and things like that. So it becomes really like a web app, in some sense. It's a web application. And also on Azure they used all the off-the-shelf solutions as much as possible for load balancing, auto scaling, client and server security, and all the web cloud solutions out there. And for the core architecture, they also used a microservices architecture based on an open source framework called Orleans, which is the same, similar stuff which I explained earlier, which is sort of a version of a service fabric PaaS that we have on Azure. And I like this slide, the title that Cristiano gave for this. They really look at the service on Azure as the Agent 47's weapon of choice. They use a bunch of services on Azure. A few of them we covered today in the talk, like web apps. We covered storage, SQL, stream analytics. They also use things like search, app insights, data factory, etc. And they're a great partner. Okay, now coming to resources. So now that you have a high-level view and understanding of Azure services for gaming, we have a few templates for you to get started from a game architecture perspective. What are your next steps? First of all, if you want to learn more about the solutions, the partners, technical details, all the link, this is the one web page you need to go. If you go to azure.com, click on solutions and go to gaming solutions, you basically get to this page. It has links for pretty much everything I covered today. And also we have a channel 9 available where we have a bunch of technical videos on different aspects that I touched today in a much more depth. I would strongly encourage you to go look at it. We'll continue to invest, put more content over there. And if you want to go deeper to understand how the Walking Dead game was built, in fact, Kale and his colleague are actually presenting a session at Build. I would strongly encourage you to go have a look at that session, and I'm sure you will like it. Call to action: check out the resources, the GitHub repository, the web, and Channel 9. Revisit the build session recordings on Channel 9, and you can continue your education on Microsoft Virtual Academy online. Thank you so much for your time.